All right, so we are going to do two practice problems from this problem set here. We're going to do one on incomplete dominance and one on codominance. And I'm doing these just so you have a reference, a model, something that you can use as a jumping point if you're kind of stuck on how to do these problems. Okay, so we're going to do number 1 from incomplete dominance, and we're going to do number 9 from codominance. Starting with number 1, coat color in mice is incompletely dominant. Yellow and white colored mice are homozygous, while cream colored mice are heterozygous. If two cream colored mice mate, what phenotypic ratio can we expect of their offspring? Show the Punnett square. All right, let's slide this out of the way here. The thing I like to do when I'm solving these problems is to first identify my phenotype, or my alleles, I'm sorry. So in this case, I have a white allele, and I have a yellow allele. Now remember, this is incomplete dominance, so it didn't tell me that one color is dominant over the other, right? In this case, neither allele is dominant over the other. So I use capital letters, and I use 2 different letters in this case. No dominant recessive, remember, no capital lowercase letter, 2 capital letters, 1 letter to represent each color trait. So I'm going to set up my Punnett square. And I'm told in the problem that we are crossing 2 cream-colored mice. Now, cream-colored mice would be the blending of these 2 colors, right? The white and the yellow. And incomplete dominance is a situation where you get a cross or a blend of 2 traits. So because my parents are both cream-colored, I want to use my alleles here to represent what they would be. So I would have one parent, that would be the cream-colored parent, and another one, another cream-colored parent. And I fill in my Punnett square. And the problem asks me for my phenotype ratios. So phenotype meaning their physical traits, right? So 25% chance of having white mice offspring, 50% chance of having cream-colored mice offspring, and 25% chance for the yellow phenotype. All right, so that's how you would do the first problem in the incomplete dominance. So now we're going to slide over and we're going to do the codominance problem. So in this one, we're told that if a roan cow were crossed with a red cow, what would be the possible phenotypes of their offspring? Roan and red. All right, I'm sorry, roan bull and red cow. So bull is the male, cow is the female. All right, so this is number 9 up here, okay? Now remember, codominance is written out differently than incomplete dominance. So let's establish our alleles first. We have the red coat color, and the capital C is for color, and then the superscript or the exponent is for the actual color, which in this case is red. And then we also have the white allele, okay? And we're told that our parents are roan and they are red. So our bull, or our father, he would be CRCW. He is, remember, roan is a representation with both red and white fur. So he would have both red and white individual fur or hair on his body, and he would look like both colors, not a blending, right? Not a pink cow, but rather a roan cow. I'm sorry, bull. And then our female, or our cow, is CRCR. So I fill in my Punnett square. All right, and we're asked what are, or to show the Punnett square, what would be the possible phenotypes for their offspring. So in this case, we have, similar to the other problem we just did, 25% chance of having red offspring, 50% chance of having, oh, I messed this up. Oh my gosh, I don't want to delete the video. Hold on. Sorry. Still getting the hang of this remote learning thing, everybody. Okay, sorry. 50% red. Good thing I didn't curse. And 50% roan. So in this case, you have half of a chance of getting red cattle and half of a chance of having roan cattle offspring. All right, and that's the codominance problem. All right, thank you everyone. Good luck.